Welcome to Innova World.
Okay, today our topic is flight mechanics, concept of airspeed indicator. So in this airspeed indicator, we are gonna make the few tricks. That is, first we will know that is ICET. That is ICE T. What the I stands for? Indicated airspeed. C stands for calibrated airspeed. E trans stands for equivalent airspeed and T stands for true airspeed. Here you can remember that this four types of airspeed by ICE T. Now we have an important formula, that is the first one related with the density. How? That is EAS by TAS equals to, that is density at altitude divided by density at sea level power 1 by 2, that is root over density of altitude at some altitude by the density of sea level. We know one more thing, the density of sea level is 1.225 kg per meter cube. The above equation, that is sigma. Sigma means that is rho of density by rho of sea level. That is density at altitude by density at sea level. That means a density ratio by sigma. So how you can memorize this word? That is E by T. E is in the alphabetical order. E comes first, then the T comes. Similarly for an A by S, that is in alphabetical order, the A comes first, then the S. So by using this word you can memorize, and the types of airspeed you can remember by ICE T. That is I, C, E and T. So what do you mean by indicated airspeed? Indicated airspeed where we measure the airspeed from the difference in pressures. Okay. So now what do you mean by calibrated airspeed? Is used to correct for instrument error, and equivalent airspeed is used to correct the compressibility effect, and whatever the true airspeed, altitude error and the difference in density in different altitude. So now how you are going to memorize? Here you see ICET. See, in between the I and C I have written the instrument error, that is starts with I, and calibrated airspeed starts with E. I have written, see, in between I have written C, and in between the equivalent airspeed and the true airspeed I have written altitude error, E I have focused it. Okay, so you remember that this ICET, in between I, C and E comes. That means when we are describing about the calibrated airspeed, that means it being followed for correcting instrument error. When we are going for the equivalent airspeed, we have to follow the C. What is C? C is the compressibility effect. And when we are finding for true airspeed, that is an error. That is what error? Altitude error by changing in density in different altitude. So this slide says about this few tricks you can remember easily about this airspeed. Now it's time to go for the few problems and few important MCQs as per gate examination. So this is a match the following. They have given the schematic diagram and this and flow. So on the opposite side list 2 they have given a sets of this matches. So here we know already, we have seen in the previous slide that what is the answer. So from there we can figure it out this answer C. Let's go to the next one. Okay, indicated airspeed. So indicated airspeed, what do you mean by indicated airspeed? Already we know it's a measurement from difference in pressure. So obviously the answer is A. Next comes the calibrated airspeed. So calibrated, we know how it is going. It is going that I, that is indicated error, this instrument error, that is a B point, that is a airspeed correcting for instrument error. That is answer is the right answer is B. Next question is equivalent airspeed. So equivalent airspeed, what we have studied is C. So the airspeed corrected for compressibility effect, that is the right answer, that is answer is C. And next comes the true airspeed. So true airspeed was the last one. So what we say, the difference in density at different altitude for altitude air corrections. So the last option is option D. Let's go to the next question. Here, what is the relationship between calibrated and true speed? So already we know the calibrated and true speed from the first equation we studied, that is E by T equals to A by S. So here this actual or the altitude density has been given as rho alone and the sea level has been given rho S. So already we remember what, that is C by T equals to A by S power 1 by 2. So here comes the, see the equation number first one, that is they have given a reciprocal format, that is T by C equals to S by A whole power 1 by 2. That is answer is a correct one, and see the hint below, so it will be easy for you to understand it. Next question, here it's a problem comes. So in this problem, see the read the problem. Here they have given that TS value, the velocity of TAS has been given in the international standard atmosphere condition, and at that same altitude you have a density of 0.526. Now what they asked to find, they asked to find the equivalent airspeed. So how we can find the equivalent airspeed? We know the formula. And what is density at sea level? Let's go and see the solution. See the given data. So VTS 100 meter per second, altitude 0.526 kg per meter cube, sea level density at sea level is 1.225 kg per meter cube. See this value, you should memorize it, you should remember this in your lifetime. Okay, now we know this relation, the formula, that is VES by VTAS equals to root rho altitude by rho sea level power 1 by 2. Now you're going to substitute all the values over there and get the equation, and we got it. See, that is 65.5. It matches with the option A. So answer is option A. Now this question, this is a GATE question asked in the year 2015. The indicated airspeed, that is IAS, of an aircraft are used for, where we, for the what reason we use for, that is takeoff, stall, lift turns, navigation, throttle adjustment, and all of the above. See, when what is the meaning of indicated airspeed? We are measuring the difference of pressure. So when we are measuring the difference of pressure, it depends on lift, stall, turn. So obviously the answer is A. Now comes the next question, the same pattern, the true airspeed that is of an aircraft are used for, that is TAS. So what does that mean by true airspeed? That is a change in density with altitude. So when there is a comes of altitude, that means we need to some height, we need to measure something, so we need to get some kind of navigation instrument. So to when we need a kind of navigation, we need to go for the true airspeed. Okay, so the answer is B. Let's come to the last question of this section or tutorial. So it's another easy question. Now you can answer it by yourself, that is VTAS and the equivalent airspeed, that is VEAS, in terms of density ratio. So what is a density ratio? I have said it's a sigma, which is already been given, that is rho by rho naught. So here what is rho naught has been explained, that it is at sea level, and rho explains that at altitude. Okay, so we know the relations from the relation, that is V by VEAS by VTAS will be equal to root over sigma. So that option comes with a C. So the answer is C.
Lecture prepared by Miss Aishwarya, Department of Aeronautical Engineering. Thank you for watching.